The second icon of evolution I wrote about is Darwin's tree of life, which is actually the heart of his theory. The only illustration he put in the origin of species was this branching tree pattern that supposedly shows how all living things descended with modification from a common ancestor at the root. Some of the evidence Darwin cited for his tree of life was the fossil record. Supposedly, if his theory were correct, if we look at the fossil record, we would see, first of all, a common ancestor and then these multiple branches coming off with, as Darwin put it himself, innumerable transitional steps in between. Because in Darwin's theory, a species gives birth to, or an organism gives birth to another organism very much like it, and only over many thousands or millions of generations do the differences appear that then result in new species and new classes and orders and so on. Well, Darwin himself knew that the fossil record did not fit that picture. He knew, for example, about the relatively sudden appearance of the major forms of animals in the Cambrian, a geological period known as the Cambrian. We now call those major forms phyla. For example, we are in one phylum, that is a phylum that includes animals with internal skeletons and soft bodies. Another phylum would be the crustaceans, or the insects, which have an external skeleton and a soft internal body. There are the starfish, there's various worm phyla, there's the mollusks that include clams and octopuses. And all of these phyla have fundamentally different body plans. In Darwin's theory, the first original ancestor would have been one of these, perhaps, one phylum. And the big differences that we now see in the different phyla would have emerged only after millions of generations. And yet, what we see in the fossil record is the major animal phyla appear at about the same time in the Cambrian explosion, what's now called the Cambrian explosion. Darwin thought the problem could be explained away by the incompleteness of the fossil record. Earlier forms had existed, they had to exist according to his theory, but they were too soft or too small to be fossilized, and so we cannot find them. But since Darwin's time, fossil hunters have found lots of fossils below the Cambrian. They're very small, soft-bodied. Some of them are bacteria that go back billions of years. So the idea that the fossils below the Cambrian, earlier than the Cambrian, have disappeared is simply false. We have found them. So the fossil record now shows that up to, from about the origin of life, up to just before the Cambrian, we have single-celled organisms, very small. And then in a relatively short period of time, we get the major animal forms. I'm not talking about all the animals. Mammals weren't there, for example, but vertebrates were there, animals with backbones, right there in the Cambrian explosion. The suddenness can be illustrated perhaps by thinking of a football field. If you were to start at one end of a football field and walk toward the other, and the football field represents the entire history of life, you'd walk 25 yards, the first line is the origin of life. The first 25 yards, small single-celled organisms. The next 25, same thing. The next 25, same thing. You've gone 75 yards, and all you have are small single-celled organisms. And then somewhere around, I think it's the 84-yard line, in the space of a single stride, the major animal forms appear. And those major forms, for the most part, are with us today. This is not a branching tree pattern, as Darwin's theory demands. This is more like a lawn than a tree. Darwin hoped that with future fossil hunting, either the transitional forms that he postulated would be found, or it would become absolutely clear that the fossil record was destroyed before the Cambrian. And both of these have turned out to be false. The transitional forms are not there, and the fossil record before the Cambrian is not all that bad. So in terms of fossils, Darwin's theory does not fit the evidence.